Welcome back. Today we're going to be talking about solving two-step equations. This is day number 2. Specifically, we're going to be working with decimals. Our content objective is students will be able to solve two-step equations with rational numbers and check their solutions. Just a quick recap, rational numbers will include fractions and decimals. Our language objective is students will be able to state the mathematical properties used when solving equations. So you're going to have to justify what exactly are you using in order for you to do that and how is it legal. And why am I learning this? Well, it's important for real life problems like helping you decide how much pet food to purchase. So our essential question is, how can we isolate a variable to figure out its value? So what could we do in order to get the variable isolated to see what the value is? So for a two-step equation like so, what you typically want to do, and this is something that I've been covering in class, is we like to focus our side, the one with the variable and the one without the variable. So here my focus is on the left-hand side. What typically you're going to want to do is undo addition or subtraction first. And for those reasons, you would be eliminating your constant first. And when you get rid of constants, you're technically trying to make it into a 0. So here, since this is plus 1 2/3, I'm going to go ahead and subtract 1 2/3 from both sides. Why am I doing this? Because by subtracting it, it will create a 0, because a positive 1 2/3 minus a 1 2/3 gives me 0, which is exactly what I need to get us to just 3x equals. So here I am going to have to do some side work. So I'm going to change this to an improper fraction, which is going to become negative, let's see, 14 plus 1 is 15. So a negative 15 halves minus, that's 3 plus 2 is 5 5/3. We're going to need a common denominator. I'm going to multiply this by 3, leaving us with negative 45 minus here. We're going to multiply this by 2. It's going to give us a 10, so you can add the opposite, leaving us with, I'm going to just start a new line, a negative 55 over 6. So we're not quite done yet. We still haven't isolated the variable quite. So this is what we're left with. So we got rid of the constant by undoing the addition. So now we're going to undo the multiplication. That's the next thing that you typically would want to do, is undo multiplication or division. And since we have 3 times x, I'm going to undo it by dividing. So this is basically when you're going to try to get rid of your coefficient. So I'm going to divide both sides by 3. So I'm going to go ahead and put divide by 3. To make things neater, I'm just going to put 3 over 1. So 3 divided by 3 is 1. That's exactly what I wanted. I wanted to create a 1. Why? Because what's 1 times x? It's just x. So I've successfully isolated it. So this is one part that some students have struggled with in the past. It's so important that you just practice by reading it out loud. This means negative 55 6 divided by 3 over 1. So I'm going to write it exactly in that order. Negative 55 over 6 divided by 3 over 1. I'm going to rewrite it as negative 55 over 6 times the reciprocal. So this is going to be 1/3. Can I cross reduce? Nope. So my answer is just going to be negative 55 over 18. Now, is this it? The answer is no. You're going to want to definitely check your work. Okay. For the sake of this lesson, I'm not going to check our work because I do want to get into the decimal two-step equations, but understand this is a required step for homework, for quizzes, and for tests. Okay. So just a quick reminder with how we would transform an equation to get to an answer. Our goal, obviously, is to get the variable by itself. Whatever we do to one side, we must do to the other. And typically, to undo an operation, we do the inverse, which is basically the opposite operation. So that's going to include addition and subtraction are inverses. Multiplication and division are inverses. They are opposite operations that undo one another. Always show all of your steps. Don't do it in your head. And last but not least, it is the easiest to undo addition or subtraction first. Okay, so here, I'm going to first separate the variable into two sides, a left and a right side. So why am I doing that? So I know where to focus. Here, since the variable is on the left, I don't really care about the right-hand side for right now. Everything is focused on the left-hand side. We typically undo addition or subtraction first. In other words, you're getting rid of the constant first. If you forgot what the constant is, it's basically a number by itself. It's not being multiplied by a variable. So here we have a negative 23.3. What's the inverse of a negative 23.3? It's just a positive 23.3. So I'm going to do it to the left-hand side, and I'm also going to do it to the right-hand side. This is going to create a 0 because these are additive inverses. That's exactly what I needed. Now it's going to leave me with negative 5c equals. Now here, we're going to do some side work. We're going to do 9 and 2/10 plus 23 and 3/10. Got to make sure I line up those decimals. It's going to give me 5. It's going to give me 12. Carry the 1. So we're left with 32.5. Am I done yet? The answer is no. My variable is still not isolated yet. So here is when we're going to do either undo the division or multiplication. And since this does mean negative 5 times c, the inverse of that would be to divide by a negative 5 to both sides. This is what's going to create our 1, which is exactly what we needed, because what's 1 times c? Just c. Now here, a positive divided by negative is a negative, so we're going to do 32.5 divided by 5. 5 cannot go into 3. It can go into 36 times. And bring, whoops, that's not a 3. 32 minus 30 is 2. Bring down the 5. 5 goes into 25 5 times, so my answer is negative 6.5. However, am I done? The answer is no. You always want to check your work and make sure that your solution is indeed an actual solution to the equation. So I need to check my work. So the way I check my work, I'm going to go ahead and repeat the exact same equation, except instead of writing a c, I'm going to put a parentheses for that. So we're going to be left with negative 23.3 minus 5, instead of a c, I'm going to put a set of parentheses, equals 9.2. So now that I've set a spot for my value of c, I can go ahead and plug in the value, which is a negative 6.5. So let's write that in. And now all I'm going to have to do is simplify and see if we end up with a true statement. If I end up with a true statement, I know my answer is correct. If I end up with a false statement, then I know I did something wrong. I need to fix it. So here we go. We're going to leave this as negative 23.3. A negative times a negative is a positive, so we're going to put plus. We're going to do 6.5 times 5. That's 25. Carry the 2, 32. So we're going to get 32.5. And this is going to equal 9 and 2/10. Now we're going to ask ourselves, do we have more negatives or do we have more positives? Definitely we say we have more positives. How many more positives are there? Well, there's 32.5 positives, and then there's 23 and 3/10 negatives. So how many more positives are than negatives? Let's find the difference. And that's going to leave me with 9 and 2/10. So guess what? Does 9 and 2/10 equals 9 and 2/10? The answer is yes. So I'm very confident that the solution is indeed negative 6.5. Okay, so let's try another one. And please ignore the numbering. The numberings are slightly off, but we're on to number 2. So first things first, I do like to separate my equation into 2 separate sides. We have a left and we have a right. The right side is where my focus is on. Why? Because that's where the variable is. So it is the easiest to undo addition or subtraction first. So we are going to get rid of this constant of plus 15. And we would get rid of that plus 15 by doing the inverse, which is to subtract 15. So notice I'm subtracting 15 from the right-hand side, and I have to subtract 15 from the left-hand side. So here, are there more negatives or are there more positives? Well, my choices is negatives or negatives, so hopefully your answer is negatives. So how many negatives do we have? Well, we have 15 negatives, put that decimal, and notice decimal belongs at the end, and we have 6 and 8 negatives, 6 and 8/10 negatives, sorry. And that's going to leave us with a total of 21 and 8/10 negatives. We have 0 positives. So how many more negatives do we have? 21 and 8/10. So we have 21 and 8/10 equals. This is going to create a 0, which is exactly what we wanted. And that's just going to leave us with a negative 3 and 2/10 x. Am I done? The answer is nope, not yet. We haven't successfully isolated x, so we still need to do that. We've undone the addition and subtraction. Now the next step would be to undo multiplication or division. Here, this is negative 3 and 2/10 times x. So the inverse of that would be for me to divide both sides by negative 3 and 2/10. Okay, so this is going to create a 1 because negative 3 and 2/10 divided by negative 3 and 2/10 is just 1. And 1 times x is x. So now here, we're going to simplify. A negative cancels another negative, leaving us with 21 and 8/10 divided by 3 and 2/10. So now I'm just going to go ahead and divide 21 and 8/10 by a 3 and 2/10. Since this is not a whole number, I am going to move my decimal one place over in both the divisor and dividend. 32 cannot go into 2. It cannot go into 21. It can go into 218. Let's see how many times. Well, I'm going to estimate 32 to be around 30. 30 is going to go into 218. Let's see. I would say about 7 times. So let's check our work. 32 times 7. That's going to be 14. Carry the 1. 22. So that's too much. So let's do 6. 32 times 6. It's going to be 12. Carry the 1. 192. That's pretty close. So let's use 6. 192. That's going to be a 6. We're going to have to borrow, leaving us with 26. So we are going to drop a 0. How many times does 32 go into 260? Real quick, let's base off of the numbers that we have. We know 7 is 224, so definitely it's going to be higher than 7. Here it's 30. So how many 30s do you think is going to make 260 roughly? I'm going to say about 8 of them, because 8 of them would give me about 240 roughly. So let's see the exact number. We're going to do 32 times 8, which is 16. Carry the 1. 24 plus 1 is 25. So that's pretty darn close. So we're going to go ahead and put an 8 here. Now that's going to leave us with a remainder of 4. Not quite done. So let's go ahead and drop another 0 down. 32 goes into 40 once, for sure, leaving us with an 8. Bringing down another 0. How many times does 32 go into 8? Let's see. I would say about, this is maybe 3 times? No, 3 times would be too much, so 2 for sure. So let's do 32 times 2, leaving us with 64. Wow, we'll keep going. Okay, so here we get left with 10. So 10 minus 4 is 6. 7 minus 6 is 1. And we gotta bring down another 0. So how many times does 32 go into 160? Well, let's see. We have 192. That's too much, so let's do less than that. So 32 goes in 160. If we estimate it to be around 30, I would say that's going to go in about 5 times. So let's try that. 32 times 5. So that's going to be 10. Carry the 1. Oh, look, it works perfectly. So here our answer is quite long, but it's going to be 6 and 8,125 10,000ths. Now, I have to check if this actually works out, so I'm going to go ahead and do that. And the way we would do that is simply by rewriting the entire equation and check to see if we end up with a true statement. So here we have negative 6 and 8/10 equals negative 3 and 2/10 parentheses plus 15. Now I am going to plug in my value that I have here for x. So let's go ahead and put that number in. We have 6 and 8,125 10,000ths. So simplifying it, I'm left with negative 6 and 8/10 equals. I'm going to have to multiply these two numbers. Ooh, that's going to be a quite large number. So for this problem, I'm going to go ahead and stack this first on top since it has more digits. So 6.8125 times 3 and 2/10. So here we're going to multiply. 5 times 2 is 10. Carry the 1. 2 times 2 is 4 plus 1 is 5. 1 times 2 is 2. 2 times 8 is 16. Carry the 1. 6 times 2 is 12 plus 1 is 13. Put a 0 here. 3 times 5 is 15. Carry the 1. 3 times 2 is 6 plus 1 is 7. 3 times 1 is 3. 3 times 8 is 24, so carry the 2. 6 times 3 is 18 plus 2 is 20. Now we can add these digits together. So this is 10, that's 0. This is 10. This is another 10. This is another 10. This is 8. This is a 1. There's a 2. So I'm going to move my decimal over a total of 1, 2, 3, 4, 5. So here we go. 1, 2, 3, 4, 5. So this is going to leave me with a negative y, because a negative times positive is a negative. 21.8 plus 15. So now we're going to go ahead and look to see if there's more negatives or more positives. Definitely going to go with there's more negatives. There's 21.8 negatives and then 15 positives. Notice the decimal belongs at the end, just like a period at the end of a sentence. We're going to find the difference between negatives and positives. Hopefully you can see there are 6.8 more negatives than positives. So guess what? This does check out. So I'm confident that the solution is indeed 6.8125. Moving on to our very last example. So something that you're going to notice about this last problem is the fact that I see decimals and I see fractions. Hopefully, if you recall, we do prefer to put things into fractions. It's going to definitely prepare you for 8th grade. It keeps your numbers or your answers nice and exact. You're not having to round because of repeating decimals and things like that. So here, let's go ahead and separate our two sides. We have a left and a right. Our focus is going to be on the right-hand side because that's where our variable is. We're trying to isolate everything and just get it to just m equals. So we do typically undo addition or subtraction first, so that's going to get rid of our constant. Since this is 6.3, I'm going to subtract 6.3 from both sides. So here we have 9.8 minus 6.3. It's going to give us 5. That's going to give us 3. So we have positive 3.5. Why? Because there's more positives than negatives. Equals, this is going to create a 0 because 6 and 3/10 minus 6 and 3/10 is 0, leaving me with just 1/5 m. So now my focus is still going to be on the right-hand side because that's where my variable is. This does mean 1/5 times m. So since this is multiplication, the way to undo that is to divide both sides by a 1/5. What's 1/5 divided by 1/5? Just 1, which is exactly what we needed. Why? Because what's 1 times m? Just m. So now here is where you need to be careful. We do have two different signs. We have two different forms. We have one as decimal, one as a fraction. I am going to go ahead and convert this into a fraction. So this one way to read it is 3.5. Another way to read it is 3 5/10. 3.5 will look like this. 3 5/10 will look like this. Either or is correct. However, you do want to reduce this and it will look like this once you divide both the numerator and denominator by a 5. Okay, so with that said, I am going to turn it now into 2 times 3 plus 2 times 3 is 6 plus 1 is 7, which is basically 7/2 divided by 1/5. So that's what I turned it into. And again, I personally like to convert things into fractions versus decimals because it ensures that my answer is exact. I'm not having to round because of a repeating decimal or things like that. So here we go. We have 7/2 divided by 1/5, which can be rewritten as 7/2 times the reciprocal, which is 5/1. I can't cross reduce, so that's going to leave me with just 35/2. So 35/2 equals m is my answer. However, before I claim this is true, I should check my work. So let's do that very quickly. We're going to go ahead and rewrite the equation, except instead of using the variable, we're going to put parentheses. So 9.8 equals 6.3 plus 1/5 times m, which is 35/2. Okay, so we're just going to keep it exactly the way that it is because it's simplified on this side. 6.3 plus 5 and 35 have a 5 in common, so 5 divided by 5 is 1. 35 divided by 5 is 7, leaving me with 7/2. So here I'm going to have 9 8/10 equals 6 3/10 plus 7/2. So here it's up to you. You can choose to turn both into fractions or both into decimals. Since the majority of these are decimals, I am going to go ahead and try to turn this into a decimal if it does work out nicely. Guess what? 7/2 does work out nicely. 7/2 is 3.5. So let's do 9 and 8/10 equals 6 and 3/10 plus 3.5. So let's check this out. 6 and 3/10 plus 3 and 5/10. Does this work out? Yes, it does. So I'm confident that the solution to this equation is 35/2. Now, if you decide to go with using decimals, you should have gotten, let's see, 17.5. So either or, these answers are equivalent. They are both acceptable. But again, I highly suggest you get comfortable turning decimals to fraction and that be your go-to method. So guess what? That actually concludes the lesson for today. Before I end the lesson, please remember it's going to be best if you undo addition and subtraction first, which is basically going to get rid of your constant. And then second, you're going to want to get rid of your coefficient by undoing it. Multiplication or division next. So keep that in mind. As always, thank you so much for tuning in, and until next time, bye.